I'm Jonathan Halstuch. I'm the CTO of RackTop Systems, and today we're going to talk about creating a data-centric zero-trust architecture with the NIST Cybersecurity Framework. So first, let's talk about what the NIST Cybersecurity Framework is. And really, it's a high-level framework that provides a taxonomy to give you the outcomes and methodology to assess and manage those risks and outcomes around cybersecurity. It is not super prescriptive, which is a good thing. It gives you flexibility to leverage it for your organization, your outcomes, and your desires based on what you're doing and how you plan to get there. So it's less prescriptive than some of the other standards and frameworks, but that I think is a powerful function of it. And it's also undergoing a change or update as they're looking to do NIST CSF 2.0 as well. And we're participating in the working sessions for that as well. So there's 5 functional areas within the NIST cybersecurity framework. And you can see those illustrated here in this diagram. And so it starts with identify, right? That's identifying the assets you want to protect. And when it comes to data, you want to identify where they are, the value of that data, and the impact of that data if it were to be lost, interrupted, stolen, et cetera, and what your organization's tolerance for an impact to that asset or data. So if you don't have availability of that data for a few hours, a few days, weeks, or months, if the data is stolen or if the data is destroyed. And then the next function is protect, right? That's about minimizing the impact of a breach. And there's many ways you're going to do that. That's, defense in depth, multiple controls and protections. And then it's also understanding how you're going to communicate during a potential breach as well. And then, of course, detection, right? Detecting malicious and suspicious or anomalous activity. And to do that, you're really going to want to have redundancy as well and depth to how you're detecting those things. You don't want to rely on only one sensor or one technology or one product to detect things like a data breach or data theft. You want to have layers, because if an adversary is able to get around that first control or that first security measure, you want them to get caught by something else or some other technique to detect that malicious behavior. And then, of course, responding, right? During an incident, we want to quickly identify the incident. We want to contain and isolate that attack as quickly as possible. We don't want it to spread. And we want to contain it so that you can continue to operate. You don't want to have to shut things down just to contain the attack. You need to continue to deliver your critical services while isolating, reporting on, and mitigating the attack. And so, again, it's all about communications, being able to communicate what's happening in real time, containing the attack, and then mitigating in real time as well. And then, of course, recover, right? We want to go and return to that pre-attack state, return to service as quickly as possible, provide continuous communications as we have before, right? Now we're potentially communicating with our stakeholders, people affected, being able to understand clearly what happened, what was done, the actions taken, and our current state. And then we are hopefully back in that pre-attack state as well. And so from a company perspective, our product, the BrickStor security platform, addresses all 5 functional areas of the NIST cybersecurity framework. And we map that kind of into 3 phases of a cyber attack, if you think about it, right? Before, during, or after an attack. So before the attack, you're identifying where the data is, you're reducing risk and mitigating the potential impact of a breach, right? For example, when it comes to file shares or network attached storage, you want to review the access controls. You want to see, okay, who has access to this data and who is accessing this data. If you have very sensitive data that is exposed and is widely exposed, maybe everybody in the company or everybody in the organization has access to that data, but in reality, only 1 or 2 people are accessing it. Well, maybe we just restrict the access to the 1 or 2 people that need it and are using it, so that if someone's account becomes compromised, that account doesn't have access to data they never even needed to access anyway. So you're reducing and improving cyber hygiene ahead of an attack.
On that cyber hygiene piece, I think, one of the most overlooked parts of data security, in my experience anyway, has been kind of data classification. And I wonder, I obviously that falls into kind of this identify and cyber hygiene piece, but I wonder if that's something RackTop helps with, or that work that needs to be done before coming into and tying access to classes.
So we can partner. So it depends on the situation. In certain cases, we partner with other companies that can look through and inspect the data to classify the data, look for things like PII or sensitive information. The other thing that we can do, though, is we have the ability to apply labels and label the data in the file system. So with things like context security labels as part of NFS 4.2, we can actually associate that document and the levels of sensitivity. So, in the government, that could be, unclassified, secret, or top secret. In a commercial entity, that might be, sensitive or PHI, and then compartmentalize that as well, so that only those people that need access to that type of data will get it. So if it's finance related data, only the finance team. So we can definitely provide extra levels of sensitivity and segmentation and tie that into a data classification system as well. So we like to partner with other entities that are doing those labeling and classification too. And we have integrated compliance reports too that can show you all of this stuff as part of the cyber hygiene to look at, your access control list, your data disposition. Are you retaining data long enough to meet your regulatory requirements or organizational policies?
And do you support multiple taggings of those? Can it be both PII and maybe GDPR and also, I can't think of other, and also children's data, like that kind of stuff? Okay.
Yep.
Perfect.
You can have multiple tags. Yep. Definitely.
Yeah, thank you.
And so that's the before attack. Then once you detect an attack, right, you want to respond. So you want to detect it. So we're using our user behavior auditing and analysis and active defense to detect suspicious and malicious activity and then respond to that. And in certain cases, we can just alert. So maybe we see administrative access and we only want to alert on it. We don't want to stop it, but we want to alert on it and investigate. Hey, somebody's reading this data using an admin account and it's not normal. Hey, we want to investigate that. If all of a sudden they delete data, we can actually alert on that, as well as we will hold the snapshots around that period of time. And those snapshots are immutable so that if any data was destroyed or manipulated, we can restore that data as well. And if you think about a ransomware attack, we would want to do the same thing. If we detect that a user or an account is reading a bunch of files and then they're encrypting it like ransomware, we can actually block that user account and that client IP from accessing any further data. We can alert the security team through webhooks, part of that whole communication infrastructure. And we can respond and say, okay, here's what happened. These are the files that were accessed by that account. These were believed to be manipulated or changed. And then we can quickly remediate and recover. So we can identify in the incident management workflow that you'll see later in the presentation about, we'll identify which files were affected or deleted and show you how we can very rapidly restore those files out of immutable snapshots and return to service and to that pre-attack state very quickly.
Do you have easy access to look at what the differences between the snapshots and the final file are?
Yes, we do. So in the snapshots, you can look at the snapshots for a particular data set. We index the metadata and files within that snapshot. And so you can quickly see growth in the file or changes to the file. And so you can see when it was changed. And then in our incident management window, which you'll see later, we'll actually identify the last time that file was changed. So if it was only changed, 5 days before the attack phase, and then right during the attack, you can kind of reasonably believe that it was changed by the attack and had been stable for a while. So it gives you that ability. And you can review all the versions of the file to see different things at any time as well.
So if Johnny's changing his exam marks, we can see just how much of an ego he's got.
Exactly.
Okay, awesome. Thank you.
Yep. And then I think it's important to note that the solution deploys, and it's a drop-in replacement for a file share or NAS solution. It doesn't require you to deploy any agents on the endpoint, right? And that's important for a couple of reasons. People don't want to have to maintain agents. They already probably have endpoint protection, and that does great things to protect endpoints. But the challenge with that is there's lots of systems, there's devices, maybe IoT devices that can be compromised and don't have agents and will then go and try to access data. With us, we're the choke point that's analyzing all that user behavior activity. So there's no way to circumvent those security protections of that analysis by avoiding an agent or endpoint. And so we can see all that data in real time. And it's very easy to deploy. So if you look at the key features of the solution of the BrickStor security platform, we support the latest file services. So when you're looking at all the controls within the cybersecurity framework and the risk management framework, we can provide encryption end-to-end for both data at rest and data in flight. So if you're using SMB or NFS, we can both use encryption and signing for those protocols. So from the client to us, it's encrypted. And then once it gets to us, we can do space-efficient things to dedupe and compress it. And then we can do up to 2 levels of encryption. We can do an encryption per data set. So you know that an individual folder or data set's encrypted with a unique key. And then we can encrypt again at the SAN level if we're using a backend SAN, or at the drive level for a second level of encryption. And then, part of recovery and part of the cybersecurity framework is having the ability to have both snapshots that you can quickly recover an individual file from, and we'll show you that, as well as if there's a true disaster, you might need to recover from another system. If there's a system failure or if the building's wiped out, you want to be able to recover that data. And so we have the ability to replicate those snapshots efficiently over the WAN and asynchronously. We also have the ability to tier data securely to the cloud, right? We see, a lot of people are moving and have reason to leverage the cloud. We can tier data to an object store securely by compressing and encrypting the data on the primary tier of storage and then tiering it to an object store. But we compress and encrypt that data with keys you control. So when the data is encrypted, it's encrypted before it ever leaves the BrickStor, and with encryption keys controlled by the client. So if any data was accessed in the cloud, it would be all encrypted and useless because the key doesn't exist there. But you could always access that data as long as you have the encryption key at a future date to recover or to rehydrate the system. And then everything's audited. Part of that, cybersecurity framework is understanding what's happening. And so everything needs to be audited. We're auditing both what's happening into the system by a system administrator, as well as, users and applications interactions with the files through user behavior analysis. And lots of organizations can provide that audit capability, but we do it very efficiently without impacting performance. And then what really differentiates us is our active defense to actually respond to those audits. When we detect something unusual, we're with our active defense capability on box, on the controller, or in the virtual machine itself, analyzing this in real time and taking proactive defensive mechanisms to stop or alert on suspicious and malicious activity.
Maybe a really basic question here. Obviously, with BrickStor SP acting as essentially a NAS here in front of whatever other file services you might have, is this something where, let's say I have an existing NAS, am I ripping that out and replacing it for sure? Or is this something that can integrate with existing storage? Or how am I going about, day one? Obviously, I've already got data stored somewhere. How does this work in?
So it kind of depends. So if you already have, let's say, a virtualized infrastructure and you have an existing NAS and you're running it on top of that, maybe you deploy us as a virtual machine within that infrastructure and you move your most sensitive data to that virtual machine. If your existing NAS has the ability to provide block, we could basically take or carve up part of that existing storage. You present that LUN or LUNs to us via iSCSI or Fiber Channel, and then we turn that into cyber storage. So you would move that data to us, and we'd be able to protect that data and give you all that capability. The third option would be for an archive situation where we could leverage, maybe you have some existing NAS capacity, but it's going to be more for archive data. We could tier that or TDM that using our TDM capability and use that as an NFS target. But for high performance, we would either consume block off of something like a SAN or off of a NAS, or we would deploy as a virtual machine within your infrastructure. So, when you're thinking about implementing the CSF or the cybersecurity framework, you have to think about it as a framework. It's really not super prescriptive, as I mentioned. It's more of guidelines and taxonomy. So there's a common understanding about how to do that and to get an understanding between organizations. And as you're doing business with other organizations, you can explain, yes, you're following the framework. Here's how you're implementing it and things like that. It doesn't really give you very specific guidance, but it does reference other standards like the NIST risk management framework and other standards, or the ISO standards. A lot of international organizations and entities outside the US tend to point to a lot of the ISO standards. A lot of organizations within the US focus more on NIST, but there's cooperation and collaboration between there where organizations might use a mixture of both. But what's important is that you're leveraging the framework to figure out what's important to your organization. You don't want to really use it as kind of a checkbox or as the prescription to do things. You need to really understand what is important to my organization, back to the identifying and understanding why am I implementing the CSF and what's important to my business and what the intent of the framework is and the intent of the controls reference or that you're leveraging if it's the risk management framework or an ISO standard. So it's trying to understand that and then explain it as to why you are doing it this way. And also capturing why you implemented the control in that way can be helpful, because what can happen is in 5 years, things have changed and people might not understand why things were implemented that way. And you get this retrospective and revisionist history kind of situation. And I say that because a lot of times people are implementing these frameworks and changes because they do it for legal reasons or for compliance reasons or for, insurance reasons, right? And at the time, that might be the best way to do it. That might be the only technology or the path to get the best outcome for what your business needs. Over time, though, in 5 years, the threat landscape changes, as does the technology available to you, right? Things in 2018 and 2019, especially as you move into 2020, from a ransomware perspective, from a COVID perspective, really changed the landscape of how people were operating. It changed what the threats were, and the technologies available changed, right? Things like BrickStor and proactive and security within your storage, things like cyberstorage have now become part of the norm, and people are adopting that. So you have to change how you're looking at things and look at that. And so it's important to document why you did it. It's also important to understand how this control applies to your business and why you made those choices. And then you can easily defend it. But you shouldn't use the CSF as kind of a checkbox for compliance to say, I did this and now I'm fine. You really have to apply some logic and thought and understand how that's going to affect the outcomes you want to do as a business organization. And so, how does zero trust fit into all of this? Zero trust has become a buzzword that everybody's using. And I think sometimes we feel like it's a lot more marketing than reality, and some people don't understand it. But really, zero trust is this model of continuous trust evaluation. It's not having implicit trust for anything, but always saying, okay, yeah, we're going to do this, but now I'm going to keep evaluating, is this what I want to happen? And I give this example for us, for a data-centric zero trust approach, for how we're doing it at the file level, right? In a traditional file share or traditional network attached storage, an admin would go in and give you read-write permissions, for instance, to a folder or data set. You would have those read-write permissions until an admin went in again and removed those. So you could do anything you want and you have pretty much unfettered access. With a zero trust approach and with BrickStor, an admin would go in and give a user read-write permissions to that folder, but we're still evaluating trust for each file operation in real time without it sacrificing that application performance or user experience, and determining, do we want to allow that file operation to happen? If all of a sudden that user goes in and it looks like they're reading a bunch of files, encrypting them and deleting the old ones, well, that sounds like a ransomware attack. We're going to block that. We don't trust that transaction. If they're reading a lot of files, maybe we'll allow that to happen, but we're going to alert on it. And so that's that real-time zero trust model that we're implementing. And what we're seeing is that entities as a whole are moving towards a zero trust model because they're seeing it as the new future, and subject matter experts are pushing this architecture. CISA, other regulatory frameworks are adopting this. The cybersecurity executive order that was focused on the government, but will filter through to things like the NIST risk management framework and other frameworks that are adopted by private sector organizations and global organizations. We'll see that these are the standards that everyone's adopting, and that it's a more effective security architecture than what we've been used to using in the past. And so as you're looking at adopting your new architecture for infrastructure and for data, zero trust is definitely the way you're going to want to look at defending your data, and is kind of the way of the future. So with BrickStor, we're really going and putting those security controls in place and then enabling you to demonstrate compliance continuously, right? So compliance is kind of the proof that you are doing the right things and that you've implemented those security controls appropriately. And so as a solution, we want to give you the best data-centric zero trust architecture that fits within your organization to protect your data as if it were a national secret and doesn't disrupt your users' operations and experience, and can show to the stakeholders, to your external auditors, and to your partners and customers that you're taking care of their data and that you can show them through integrated compliance reports. You're not just checking the box saying, hey, I have data encrypted. We often hear people talk about, yeah, the data is encrypted at rest, but I'm not really worried about somebody stealing the whole system and running off. But they would be worried about somebody stealing files. And so we're going beyond that checkbox compliance and really saying, okay, this is what's important. These are the ways an adversary would access your data. And these are the things you need to think about in terms of cyber hygiene. These are the things you need to think about while under attack, how you're going to quickly return to that pre-attack state and communicate with your stakeholders, law enforcement, lawyers, and your customers about what happened and what was compromised, and give you that real-time visibility into what's happening in the environment.
So in the title of this presentation, you used a data-centric, which made me very happy. You had me at data. But in that title, when you say data, are you talking about the data in the files and the blocks? Are you talking about the configuration of BrickStor? Are you talking about monitoring and observability? Like, which data is making this data-centric?
Really, it's the files, right? So think of us as storing lots of unstructured data and files, and even databases tend to get exported into files, right? People export data from a database into a spreadsheet or, CSV, and then it's there. We're protecting all of that unstructured data, which typically makes up 80 to 90% of what an enterprise works with. That's the data where we're talking about. It's your network home shares, it's the medical imaging, all of the data that you're consuming on a normal day. That's what we're protecting. We're analyzing how it's being accessed, who's accessing it, and from where.
Excellent. So now I have to ask my obligatory question, because you use the term unstructured data. So there's lots of different definitions. Is yours basically non-relational data or non-DBMS, no matter what the data model is? Is that what you mean?
Yeah, it's kind of like that stuff that's not accessed through like a query, like a database query. It's the stuff that's sitting out there. Now, if you have a bunch of backend flat files behind that database, I would say that should be sitting on us, and we can protect that too.
Or JSON files or XML files and all that stuff. Okay, thank you.
I was fortunate to get to see you guys back last March. It was the first go around, and I'm real excited about the solution. And Alice, I'm really starting to dive in more, right, to become a partner. Could you kind of touch base? I know there's a few different, options with the BrickStor SP solution, right? Like there's a turnkey appliance, and then, kind of replacing a physical SAN. Can you touch base on the cloud piece? I know, especially with, AWS, Microsoft, Azure, and so forth. Can you touch base on that a little bit?
Sure. So as a virtual instance, we can deploy in all three of the hyperscalers, AWS, Azure, or GCP. And it's the same software, no matter if you deploy as an appliance or as a virtual machine on-prem or in the cloud. So that means it's completely interoperable, right? And so we can protect your data wherever you need it, whether it's at the core, the edge, or the cloud. And you can replicate, for instance, data from, an on-prem instance to an instance in the cloud, or we have customers replicating from a virtual instance in Azure to a virtual instance in AWS. And then we can also sit cloud adjacent. As more and more people look to deploy to the edge, we can, use high-speed connects to a cloud and provide those file capabilities to any sort of cloud through that way as well.